The new 5.7 PCG Paint mode is pretty nice. It allows you to, well, paint or just click and place. But one thing it doesn't do, as you can see, is actually care about the size of the brush. I am painting with a wide brush, but I'm still only painting one line. Well, I'll be showing you guys how I create this, where it actually places it in the size and shape of your brush. As you can see, we're just placing a few in a circle, and I can go ahead and change the spacing of these so we get a nice dense area. So you can see it is indeed placing them in a circle, and I can change it to a box, and I'll place it into a box. Now it's hard to tell because it is really dense right now. But you can see it is squared off on all sides here, and when we go with a circle and I click and drag, it is ending in a rounded point. And with a simple setup here, with a simple control, you can then remove overlapping points and just keep a nice dense forest that you can paint. This is the full size brush, but just to show, if I made the brush considerably smaller, I will draw, of course, a considerably smaller area here, just like that. Nice and simple. So let me show you how everything is set up. To get started, as always, go to Edit, Plugins, search for PCG, and make sure your procedural content generation framework PCG is enabled, and restart your engine as needed. Thanks to the new PCG mode, we don't even need to create an actor, we just need to create the graph. So let's do that. Right click, go to PCG, grab yourself a PCG graph, an empty graph, and this is going to be our PCG underscore foliage brush. And go ahead and open it. The first thing we're going to do here is actually go right into the detailed panel here. And under tool data, this is where we can customize what we actually display and see when we try to access it. So the display name, I'm going to call this foliage brush. In the tool tab, I just put in something like paint, similar to how the foliage brush works. Not super important, but we have something in there. And now we have to add the compatible tool tags. If you've seen my overview video on how all of the PCG mode stuff works, you'll know that to put this in is very simple. It's just paint tool. It is a thing that it is in terms of the mode, and then the word tool. So if I was to change the selection mode here to PCG and go under paint, you can see the type here is paint. So it is paint tool. The actor that we're going to be attaching to is a regular actor. That is fine. And then new actor label, which is the name of it, we'll just call this foliage brush tool. And we'll go ahead and make sure it is enabled as a preset, so we have the option of seeing it. Once we click here and paint, you should see foliage brush right there. Now if I click it, you'll see we have no options here, pretty much except the default ones. So let's go ahead and actually customize this to, we'll do something, because we can paint something, but nothing will happen. To access the point that's already going to be painted, we need to right click and search for get tool data. This new node gets us the information we need. We need to specify which tool we're using. So the tool tag again is paint tool, and the data instance is the name of the data you want to pipe it into. You could put in multiple here, and we'll do one for square, one for circle, so you can use different brush shapes. Or if you only want one, you can of course just set up that part of it. So for the first one, I'll call this circle brush, and then I'll go ahead also duplicate it, and the other one I'll call square brush. I'll have square brush on top and circle brush on the bottom, and then because we'll probably need to access this down the line, I'll drag out of both, search for name, and use the add name declaration node, and then press F2 to rename it, and this is just going to be our squared brush points. And same thing here, add a declaration reroute node, and this is going to be our circle brush points. So that way we can go ahead and use these anywhere else, and we don't have to kind of grab these from everywhere. So let's start with a square. If we were already right click and just do square brush points, we can immediately, if we wanted to, use a static mesh spawner, plug something in, and then if we go back here and then re-click on it, it will refresh it, and you'll see here under data instance, there's our circle brush and our square brush. We just set up the square one, so if I select square brush and then zoom in and then click and drag, you will see there's our squares, all spawning with the spacing that we've specified from right here. Minimum point spacing I have at 500, is why we're getting so many. If I change the brush size to 10, it is still going to place only one though at that spacing. We now want to actually go with the size of the brush. And by the way, when you're here, do not press Control Z. Control Z will undo your last action, not what's being done here. If you want to reset this view without resetting everything you've set up here, just click this reset button next to your data instance. Click reset, and there you go. It's all good. Going back here, there's a few things to note that we're actually getting information from. So if I was to click on the squared brush and press A on here, we have nothing drawn anymore because we've reset. So let me just draw a few boxes here. And now by pressing A, we have the information of these boxes. What do we know? We know its position. We know its rotation, if it was projected on something that's a curved surface. Its scale is always 1. Its bounds are based on the actual brush brush size. So we can use the bounds as the brush, and then density is all set to 1. And we're not going to be making use of it, but just know that the strength is what controls the density. If I change the strength here to 0.2 and then draw some more squares here, you will see down below, there's our points that are 0.2 density. So you can already paint things at different densities and sample that if you'd like. But the main one we need here is the actual basic diameter or radius of this whole thing. So what we're going to do is from the squared brush points, we're going to get started with it here. I'm going to drag out and search for set attribute. And we're going to plug in the same thing into the top and bottom. And basically what I want to do is save the extents. The extents is basically half of the diameter of that point, assuming it's a sphere, but these are all perfect cubes. So effectively it is the radius. So for the input source 1 and 2, I'm going to change these to be extents, but I don't want to save it onto itself from itself. I want to save it to a new attribute. So here I'm going to call this radius. Aside from the radius, I want to know what is the spacing inside of that radius. So we're going to add our first new attribute. In the bottom left here, under graph parameters, we're going to add a new parameter. I'll select it, press F2, and call this point spacing, and I'll leave it at 100 by default. Let's go ahead and put it into a category right away. So by pressing this down arrow here, we can go to category and then type in the category we want. So I'm going to call this under spawning. Now, be careful, pressing enter doesn't actually submit that value. With the thing typed in, click back on category, and then you'll see under parameters, spawning, there's our point spacing. If I was to change the category here to spawning A and click away, it also works, as you can see. It just cannot be enter. If you press enter, it will put a new line, and you can have multiple things here on multiple lines. Again, I click away, and you can see the category is now 2 lines of text. I'll go ahead and just put in spawning, and there we go. So I want to go ahead and add this, so I'll drag this out, and then we'll use a regular add attribute under the parameter section, because we're adding a parameter. Point spacing goes into attributes, and because I want it to be called the same, I could put in the output target as point spacing, or I can say copy all attributes, and this will make it so the name of the attribute is automatically point spacing. Either one will work, but if you want to ever change it, this is the simple way. Just put it into output target. So how are we actually going to get all of these points? Well, we're going to create a grid based on the radius and the point spacing. That'll determine how much we're actually spawning, how big of an area, and how many points are in that area. Now, because we can use different radius of brush, we do need to make a loop for this. We need to loop at every single radius and adjust accordingly. So for that, I'm just going to right click, go to PCG graph, and we'll create another empty graph. This is going to be our PCG loop underscore copy points. Then you can go ahead and click on it and drag it up and select the bottom option to create a loop node. And then with this node, just double click on it and open it up. For the input, we don't actually want to create points for once, but we do want to change it to a loop, and we want a pin status to be required. The allowed type should be any, because that is the type of point we're using. You can see it turns it to this gray point-like icon, which is basically what we're using. So we can leave it on any, but the output is still going to take only points and is going to be set to normal. So great. Now we can plug this through, but first we need to separate all the points based on the radius of brush we used. So from here, we drag out and you search for an attribute partition. And in the detail panel, we'll just change this at last to radius. I'm going to show you what happens actually for this attribute partition, but first let's go ahead and plug in the static mesh spawner again. And then we can go back to the foliage brush, just re-click on it to refresh it, select square brush, since that's what we're working with. And now we can go ahead and paint it. As you can see, there's our small cubes. And if we change the brush size here to the max of 10, we can go ahead and draw some at 10. And now if we go to attribute partition and press A, just make sure to reselect it in the bottom left corner. You will see when we go all the way to the right here, there's our radius, it's an X, Y, and Z, and there's our point spacing. But because we've separated out, we have another point of data where we're selected, and you'll see there's our radius for the bigger points. That's 1, and then the other separated out by radius. So fantastic, that is working great. Let's go ahead and plug that all the way through to our now copy points loop. Let's go back inside and set this up. If you see this icon, don't worry. This is just because we're currently debugging something and is not using it, which is why it's disabled. But all we need to do is from here, just drag out and search for get attribute from point index. It'll go ahead and create a conversion node along with this get attribute from point index. The input source here will use radius. I want to get the radius of these points, and I also want to get on a second copy of it the point spacing, so we know how big of an area and how wide apart. The only thing that we need to change here is on this radius, it is X, Y, and Z. We want to flatten that height. We just want a pancake. So dragging out of this attribute, we can use a set attribute node with setting to B to 1, and we want to specifically set radius.z. So only the Z axis will be set to 1. So effectively just taking it and flattened it. And now we can right click and search for create point grid and open this up. This now takes in grid grid extents and cell size. Cell size is our point spacing. That is going to go into cell size, and our radius here is going to grid extents. We can go ahead and close this up now, and the only thing left to do is we want to actually put these where the original points were. So we'll move this a little down, and then we can copy one to the other. So I'll drag out of the create points grid, search for copy points. That is our source, and we're copying them to the input, the original locations. And then the output of these copy points is what we're actually outputting. So overall, a very simple graph here. But now already using this, I can go ahead and reattach the static mesh spawner, and immediately you will see something different. If I go ahead and reset this with the square brush selected, if I click, I get a square. Now, this is hard to actually visualize where the square will be. So I'll go ahead and reset it. And then down below under brush mode, I'll just select box. And if I go ahead and now click, you will see we get an exact box of that size. If I go ahead and change the size of the brush, let's say to 3, we have a small one. If I click, we get a small box. So already we have a brush here that is the exact size we want relative to the brush shape. So let's go ahead and from here, let's set up the circle version. The circle version is actually going to be quite simple because we're going to be reusing most of this and adding just a little bit on top of it. Now right click and search for circle brush points. And we're going to do the same thing with this. So we're going to take all of this, duplicate it, and just plug it all the way through. Now it is going to throw an error in here saying attribute radius not found. This is because we have not drawn anything with the circle brush here. If I go ahead and select it, we can even select the sphere option for the brush mode. If I go ahead and click and drag, just you're not seeing any points, but under the hood, it has created them. So the error has gone away. But just know that everything is fine. It's because we're debugging it and it doesn't see those points. So it throws an error. As you're creating this, you can ignore it if you're not currently debugging. But awesome, we've created another grid. So now all we need to do is filter out them by distance. We'll just drag out and search for distance, and we want the spatial distance version. Don't accidentally grab the vector operation, which is the one that selects by default. This is different. You can see here. We want the point one. And then we want to go grab the circle brush points, and then we'll plug that into the target. So it is going to check the distance from our original points to the target. And inside of our distance nodes, you will see is outputting to the distance. There is a maximum distance at which it checks, but it'll never go this high, so that's fine. And if I go ahead and press A here and scroll to the right, you will see there's our distance. Minus 1000, minus, and you can see something, they're all negative here. Pretty much every single one here is negative. From the distance, I'm going to select absolute and then press A here, and you'll see all of our distance values have become positive. And that just makes it a little bit easier to deal with because now we can go ahead and use a filter. By using an attribute filter, we can plug it into the in and the filter here because we're going to check that the operator is less or equal to based on the distance, and we're comparing it to radius.x. Now it's going to throw us a warning. Threshold point data doesn't have the same number of elements, so really it's complaining because we have multiple points of data. And at this point, we don't need multiple points of data because this partition we're good with. So after this absolute, we can go use a merge points here and then plug it through to the filter attributes, and you see it no longer complains. If I go ahead and take all of this and then from the inside filter plug it into static mesh spawner, you will see we effectively have the exact opposite of what we want. Well, what happened here? We specified that we want the radius to be less or equal to the value we will set. Well, the original values were negative. So really, they got flipped when we set them to positive. So really what we want to do is on this attribute filter, instead of less or equal to, we want to do greater or equal to. And when we do that, we now have different values. So now I can go ahead and click and drag. This is our 10. And now if I change the 10 to a 3, I can click and drag and paint ourselves a 3. So just like that, we can go ahead and start dragging and painting here. Change the size, and we can go ahead and make a big happy face. So this is all great. We can now swap between them. We can select the square brush and the box brush and then put in square section. So this is good. Now let's go ahead and customize this so we can actually, well, use it like an actual setup. I'll go ahead and just reset the square brush and the circle brush. And if you go ahead and cancel out of the paint tool entirely, the errors will go away so you are not debugging things with errors during this. So let's go ahead and set up the actual meshes that we want to spawn, the transforms, and all of that kind of stuff. Let's start under graph parameters, adding some variables. The first variable here, we're going to add the static mesh. So we're going to hit this capsule here on the left, search for static mesh, and we want to get a static mesh object reference. And I'll hit the old drop down here, and we'll change this to be an array. And I'll click on new property, press F2, and name this to meshes to spawn. And by default, we'll go ahead and add one in here. That's just going to be the default 1 meter cube with socket. That is fine for our default. And we'll put it with the spawning. So again, press the drop down category and type in spawning and then click away. And you'll see there it is. You can go ahead and click and drag it and reorder this. Nice and simple. We're also going to have the option of pruning things that are overlapping. So we'll go ahead and add a new Boolean here. I'll rename this to prune overlapping. And what I can do now is actually click and drag, and I can just put it right here in between the point spacing, and it'll put it in the category. You don't have to type it every time. You can just click and drag it. But just note that you will never get a drop down like you would in normal blueprints. Maybe in a future version. That's all our spawning setup. Let's go ahead and add some variables for offsets. So we'll change this one to be a transform, and we're going to rename it to global transform. This is going to be our overall globally. If you want to just move everything up, down, left, rotate it, whatever you want, that's going to go into global transform. Then we'll have one more transform that's going to be our random transform min, and one more that is going to be, again, another transform points that's renamed to random transform max. Now, by default, it goes ahead and sets scale to 1.0, rotation 0, location 0. So this is great for defaults. All we'll do is just select one of these, go to category, and I'll put in a category called offsets. You can type it in, click away. There it is. And now we can go ahead and just click and drag the other ones kind of above it and position this where we want. I probably want global on top of the random. So there we go. So now we have global, random min, random max. I'll also want a few controls for these offsets. The first one is going to be a Boolean, and I want to know if I want to do uniform scaling. Now it'll be on by default. And the other one I want is another Boolean, and I want to know, do I want to do absolute rotation, which will be off by default. And again, I'll just go ahead and just click these and just drag them up and then reorder these accordingly. It's a little bit faster than actually typing it in every single time for every category. So that's all our offsets. So let's go ahead and take care of those, as well as our meshes to spawn. We'll go ahead and take care of the offsets first. So I'll detach the static mesh spawner here, and then we'll grab a transform points node, open it up, and then we'll have the offsets as we had before. So now we can grab the global transform here, drag it in, and then we can drag out from it and search break transform attribute, which will get us the translation, rotation, and scale, which we can plug into offsets, rotations, and scale just like that. Then we can drag in our uniform scaling and plug that through. And we also have the absolute rotation to, again, drag through and plug in like so. So in the end, we have everything here plugged in, and then we can go ahead and use this. Now we're going to need the same thing. So I'll pretty much duplicate everything except the global transform here. We don't want to use absolute rotation here because we already set absolute rotation here. It's already set as our global. And then from here, it's modifying it based off the absolute rotation we already set here. So for trees, this would make them face up, and then you can still give them a little bit of randomness from there to move whichever way. The main difference here is we want two of these break transforms because one of them is going into the maxes and one is going to the minimums. So before we plug these in, because you can see it's trying to use a conversion, that's because we haven't plugged anything into the in. I'll drag in the random minimum and the random maximum here. And then now from the max, we can go ahead and plug that into the max values of rotation, translation, everything. So nice and simple. Transform variables are great when you have all three values. Instead of making 6 variables for location, rotation, and scale, min, max, you just create 2, a min and a max. From here, we can already try this out. If we go ahead and plug in the static mesh spawner at the end, you just need to make sure that both of them are going into the transform points, because while this beginning section is different, everything from here on is the same of both. We'll go back into our foliage brush, and now you'll see here under offsets, we can go ahead and give them a little bit of control. So we can tell it, okay, offset between negative 100 and positive 100 in the location. And I would love to go between 0 and 360 in the rotation, but here's the thing. For some reason, it doesn't let you type in 360. It only allows you to do 180 and negative 180, which is really odd because you can see that the actual slider here does not actually go to the end. You can't make it go all the way to the end. I don't know why this is, but just know it's negative 180 to 180. That gets you the 0 to 360 like you normally would. We go ahead and tell it to be aim for 1 to 2 scale. And you know what? We'll do 2 across all, and we'll turn off uniform scaling to really test this. Only thing left to do is I'll change this point spacing to be 200. And now if I go ahead and click and drag, you could see there's our cubes. That's working really well. If I dynamically now change the point spacing after the fact, you could see that has worked really nicely. There's our cubes. They're all randomly rotating, randomly scaling, not uniformly. And if we go ahead and turn off uniform scaling, you can see that is the only thing that is changing. And then we can swap to the box mode and the square brush here. And now we can draw a box shape. Fantastic. So let's go ahead and set up the pruning next. So I'll grab the prune overlapping, drag it through, and what I'm going to do is use a simple branch node. And when this is true, we will output to B. So by default, when this is not true, we're outputting to A. So immediately we can plug that all the way through here. But when we output to B, when prune overlapping is true, I want to first merge all the points. So that way it will combine the circle ones and the square ones. So it's all together. And then just do a simple self-pruning. The default here is large to small, which is great for us. And then we just plug that all the way through. So now if I go ahead and change the point spacing to something like 200, I can go ahead and turn on prune overlapping. And you can see they have now no longer overlapping each other. Now, how does this work? It's because every single bound of these points is 200. So within 200 distance, none of them will ever overlap. If I change this to 100, you'll see we get a lot more. 300 less. So you can dynamically just choose this as your pruning and guaranteeing that points will never be closer than this distance. Sort of like the foliage mode, where you could specify things to never actually be touching each other. Always have at least some distance apart. This allows that with a simple checkbox. Now we're still spawning only cubes. We want to make use of these meshes to spawn. So let's go ahead and take them, drag them in, and then all we need to do is use a match and set attributes node, and the meshes to spawn is going to go into match data, and we're going to put that right before the static mesh spawner, just like so. Now, because we want to use these meshes now, in our static mesh spawner, we're going to change the mesh selector type to by attribute, the top option, and the attribute is what we called it here. So it is meshes to spawn. If you named your variable something else, you can go ahead and adjust this name accordingly. And nothing has changed here because we're still defaulting cubes. If I now change this to, for example, a tree, well, there you go. We now have trees, and go ahead and get ourselves a few different trees here. We can increase the spacing because they are quite dense. And there we go. So now we can go ahead and just paint a forest where we can guarantee that they're never going to be too close together. I can just put them as close as I want here, and they will effectively never overlap. Nice and simple. Now, there is one thing that still could be improved, and that is the eraser part. If I press shift, it is hard to know where I need to place the points here to erase them. So as our final thing, I want to add a debug vision where I can see where are the original points that I'm trying to erase. Because maybe I set up the offset and location to be quite bigger. Let's say minus 1000 to 1000. So now there's a nice big variation here, but now the points are potentially further away, especially if I go crazy and I just made this minus to plus 10,000. The original points were somewhere in here, but you can see everything still works. And thanks to the pruning, it all works really well. We can turn off the prune overlapping, and you'll see we now have, there's that dense forest in the middle, and it is effectively naturally getting thinned out at the edges thanks to the randomness. For the debugging, we'll add a new parameter here. It's going to be just Ava type Boolean, and I'll call this debug original points. I'll go ahead and just place it right over here, and then all we need to do is use a branch. And the reason I'm putting it here is because I want both the squared and the circle points, the original ones, to go in here, so that way we don't have to draw them out somewhere else. They're already conveniently here. Might as well use them. So on output A means it is off, so we don't want to do anything. But in output B, I want to use a bounds modifier because I want to scale these points. And really, it's not scale. I want to set them. I want to set them to be minus 50 in X, Y, and Z to 50 in X and Y. But for the maximum Z, I'm going to set them to be 5,000. And then from here, I'll drag out and just add ourselves a regular debug node. So nice and simple system. But now on the left here, you can see there's our debug original points. We can enable it and turn it on, and that's where our points are. That's where we have drew all of the points. So you can see them. And now if I go ahead and just hold shift on these points, I can go ahead and erase these specific points. Now it is a very large scattering, so it's, it's difficult to tell still which ones you need to erase, but normally you probably won't go that extreme with the offsets. Instead, you'll probably just draw more of them. But when it's something like this, the reason it's so high is so that way you could see them from anywhere, even when you have trees or very tall objects that you're spawning. And now we can just go ahead and erase or draw new ones, swap the brush mode, and paint ones, as you see. And if we're happy, we eventually hit accept. And in the outliner here, you see there's our foliage brush tool named as we want. And we can always, with it selected, go back to the paint mode, go back to the foliage brush, change our size back, and then erase the points and draw new ones. And yes, even the actual slope works. As you can see right now, it is all angled. But that is why we did absolute rotation. And so we can have things like trees actually follow up. Now there's a ton of controls you can still add to the system. But what I've shown you here hopefully has explained to you how do you use different sections, how do you have multiple layers in terms of like maybe square and circle brushes, how do you hit attributes for global, for certain section, etc. etc. And hopefully a bit more than that. Now, as always, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord is down below as always. And if you're just getting familiar with 5.7, I recommend checking out my previous video on all things PCG mode, because it is quite powerful and awesome. You can check it out right here. Come on. You know you want to.